Dear students, in the last video we have discussed drug loading capacity or estimation of drug loading capacity of nanoparticular dispersions. So in this video let us discuss about the in vitro drug release studies of nanoparticles. Okay. In vitro drug release studies are mainly useful for quality control as well as the prediction of in vivo characteristics or in vivo kinetics of drug release after nanoparticles are injected into the body. But unfortunately, due to very small size of these particles, the release rate observed in vivo can differ greatly from the release obtained in a buffer solution in vitro. However, in vitro release studies remains a very useful quality control tool as well as for evaluation of the influence of various formulation as well as process parameters on the release rate of the active components, nothing but active drug. In vitro release studies profile from nanoparticles can be evaluated by various experimental methods. Okay, the release profile of a drug can be conducted using a dialysis tubing or without using a dialysis tubing. Okay, so dialysis tubing means uh, it contain it is a tube covered with a dialysis sac, okay, in which we will fill the nanoparticles or nanoparticular dispersion and do hermetic seal, and this hermetically sealed dialysis tube will be introduced into the release media or release medium or dissolution medium, which is maintained at a particular temperature and agitation speed or stirring speed, okay, and having a specific composition similar to the dissolution media that we normally use in dissolution testing of solid dosage forms like tablets, capsules, uh, liquid orals, etc. So in dialysis, the nanoparticle dispersion is introduced into pre-washed dialysis tubing, which is then hermetically sealed. This dialysis sac is dialyzed against a dissolution medium at constant temperature with constant stirring. The released drug diffuses through the dialysis membrane, and samples from the dissolution medium will be taken at different time intervals, and samples were subjected to centrifugation and finally analyzed for the drug content. Okay. Sink conditions must be maintained during the release studies. Okay, you might be knowing what are sink conditions. Okay, in biopharmaceutics you might have studied about sink conditions. Sink conditions is a condition in which the a condition that is characterized by uh, a concentration gradient from the diffusion layer to the surrounding dissolution medium. I repeat once again, a sink condition is a condition in the dissolution medium, okay, which is characterized by maintenance of a concentration gradient from the aqueous diffusion layer surrounding the dosage form to the surrounding bulk medium or surrounding bulk dissolution medium, that is called as sink condition. Okay, so sink conditions must be maintained during the release study. Without sink conditions, the any dissolution study or any release study will not be the valid one, will not be the valid one, or okay, there is no meaning of conducting any dissolution study or release study without maintaining sink condition. Okay, so here also we will maintain sink conditions. A scientist called Washington in the year 1989 criticized this method and claimed that perfect sink conditions are not maintained during release studies, since nanoparticle dispersions are not directly diluted in the dissolution medium. As a result, the rate of drug appearance in the dissolution medium does not reflect the rate of release rate from the nanoparticles, but rather the concentration gradient between the continuous phase of the nanoparticle dispersion and the dissolution medium. Okay, and later the two scientists called Levy and Benita in the year 1990 reported a technique which avoids the enclosure of the colloidal drug carrier in the dialysis sac, and this technique is based on the reverse dialysis. In this technique, the nanoparticular dispersion is directly diluted in the release medium so that perfect sink conditions can be maintained. Okay, and a number of small dialysis sacs containing 1 ml of the buffer are suspended in the release medium for monitoring of amount of drug release. Okay, and the main drawback of this method is that it is not sensitive enough to characterize rapid release rate of the drug from the colloidal carrier or nanoparticles. Colloidal carriers means nanoparticles. However, it can be assumed that if the drug is released over a prolonged period of time, that is usually more than 1 hour, then this method can be used for in vitro release profile investigation from the nanoparticles. Okay, so first I told you how a release study can be performed using a dialysis process, or by enclosing the nanoparticle dispersion in a dialysis tubing, and due to the non-perfection of non-perfection of maintaining sink conditions, I started discussing about a dissolution study or a dissolution test where nanoparticles are directly mixed with the dissolution medium without enclosing any dialysis tubing or dialysis sac. Okay, in the latter case, the perfect sink conditions, okay, were maintained. Okay, now the in vitro kinetic methods based on dilution and separation employ direct dispersion of lipid nanoparticles or nanoparticles in the release medium. At specified time intervals, samples of diluted dispersion or, or solution are withdrawn. After separation of solution from the nanoparticles, the amount of drug released into the solution will be determined. This method is efficient only if successful and rapid separation of nanoparticles from the aqueous phase is achieved to prevent further drug release in release medium after sampling. Okay, what we'll do, we'll put nanoparticles into the dissolution medium, and we'll start collecting this, and dissolution goes on. Okay, dissolution process goes on. We'll collect the samples at different time intervals. Okay, we'll collect the samples of dissolution medium at different time intervals. The samples may contain nanoparticles. Okay, so here we have to separate the nanoparticles from the collected sample of dissolution medium. Okay, and then go for assaying of the collected sample of dissolution medium. Okay, and if we can make this rapidly or quickly, okay, we can able to do this process, or we can uh, accurately, or with good precision. Otherwise, the the total process of dissolution study and interpretation of its results will become cumbersome. Okay, this is mainly due to the small size of the nanoparticles. Okay, why? Because it is difficult to separate very small size of particles from any liquid. Okay, that is not easy. So this is about in vitro resolution studies, and coming to the other analytical aspects of nanoparticles or nanoparticular dispersions. Okay, are rheology and storage stability. Okay, so nanoparticle dispersion is also a dispersion, and the dispersion medium should be of certain viscosity, and should show some relevant rheological characteristics, like nature of flow. Okay, isn't it? Like, either Newtonian flow or non-Newtonian flow, etc. So, rheological measurements of nanoparticle dispersions will be conducted using Brookfield viscometer. Okay, using an appropriate spindle, and here you already know what are the factors affecting the colloidal dispersion, viscosity of the what are the factors affecting the viscosity of the colloidal dispersion. Okay, both the uh, concentration of the dispersed phase particle, composition of the dispersion medium, okay, surrounding temperature, all will affect the viscosity of the dispersion. Okay, here also same, in case of nanoparticular dispersion. Okay, and as we go on increase the concentration of dispersed phase, nanoparticle concentration of number of as we go on increase the number of nanoparticles in the dispersion, nanoparticular dispersion, the flow nature of the dispersion changes from Newtonian to non-Newtonian, with simultaneous increase in the viscosity of the dispersion. Okay, so final parameter of pharmaceutical analysis of nanoparticles or nanoparticle dispersions is storage stability. Okay, the physical stability of the nanoparticle dispersions during prolonged storage can be determined by monitoring the changes in the particle size distribution, drug loading capacity or drug content, appearance, viscosity, and other rheological aspects of the dispersion. as a function of time, as a function of time. Okay, nothing but soon after preparation of the dispersion, nanoparticle dispersion, we have to evaluate the dispersion for these parameters. Okay, and during the total period of storage at different time intervals, or during the total period of stability study at different time intervals, we have to collect the samples and perform the analysis for these parameters to check whether the values of parameters were changed or not, were significantly changed or not. Okay, if the change is not significantly, then there will not be any stability problem. Otherwise, there will okay that otherwise it indicates a stability problem. Okay, so this is about storage stability. Nothing but in storage stability, we have to evaluate the nanoparticles or nanoparticle dispersions for all the parameters, almost all the parameters. Okay, that we usually check as a routine quality control uh, parameters. Okay, so I am ending my discussion with at this time. Okay, and I will continue my discussion in the next video. Thank you.